The ice is moving all over Greenland. The inland ice is in motion, and presently more than 430 cubic kilometers of ice leave the bedrock every year and work their way into the sea, causing the oceans to rise. This is a rate of loss we have never observed before. Enormous forces are at play, and the movements are controlled by mechanisms we have only just begun to understand.
The amount of ice flowing out of here may be as much as double what it was 10 years ago. And that is causing lowering of the surface because the ice gets pulled out and stretched, and it's just not being replaced from the ice sheet fast enough.
It has really come as a surprise to all of us that the ice has been able to increase its speed so dramatically during the recent years.
The melting pattern of the Greenland ice sheet has now moved towards the northern part of Greenland, where it's very responsive to very large outlet glaciers that can lose a large volume of ice from Greenland.
For more than 4,000 years, people have been living along the coast of Greenland. The sea has always played a significant role for the people living on Greenland. The sea is where they get their food and what has made life on the world's biggest island possible. Even though the majority of Greenland's inhabitants no longer work directly with fishing, Greenland is still totally dependent on fishing and the surrounding sea. We know that the biological balance of the ocean will be changed with the huge amounts of fresh water that enter the ocean along the coast of Greenland. We know that the impact of the sun on the ocean will change as the sea ice disappears. We just don't know what that will mean in the long run. But it begins here.
People in Greenland are used to changes. Greenland will experience large consequences of climate change, but it's not where the most severe consequences will be felt. That would be in more heavily populated areas.
We are witnessing the beginning of a development that means we have to reconsider our view of the role the Greenland ice sheet plays in the global climate. The ice has started its melting and has now become relevant to all the people of this world. Already now we see processes running that are creating a massive unbalance, and this means we have to re-evaluate Greenland's contribution to the rise in sea level.
In the IPCC report from 2007, it was concluded that the mean value of the expected sea level rise during the next 100 years was 40 centimeters. It was, however, mentioned that the upper limit was very uncertain due to the lacking understanding of the fast-flowing ice, the processes there. So this has been a challenge to us, and we have worked on that during the recent years. And the new values of the expected sea level rise are more of the order 1 meter during the next century. So this has dramatically changed our prediction of the sea level rise we can expect in our future.
The inland ice consists of more than 3 million cubic kilometers of ice, which amounts to 10% of the combined ice mass on this planet. Over the years, scientists have utilized many different measuring methods in order to obtain knowledge about the amount of ice and meltwater that leaves the bedrock. The objective is to be able to determine how much is melting, how much ice is running into the oceans, and how fast it is happening. Measurement methods used include airborne laser measurements along the coastline of Greenland, meteorological measurements, ice core drilling, GPS and satellite, and all these methods tell one and the same story. The ice mass is decreasing faster than ever observed before. If the ice should disappear completely from Greenland, which would take at least 1,000 years, the bedrock would rise more than 1 kilometer above its current surface. This would send enormous masses of water into the oceans, with the result that the sea level would rise about 7 meters, changing the world as we know it.
In the early predictions of sea level rise, the main contributors to the sea level rise was the thermal expansion of the ocean water and the contributions from the small glaciers. But this picture is actually changing. In the new predictions and the predictions from the future, it's the big ice sheets, it's Greenland and Antarctica that will become the big contributors to the sea level rise we will see in the future.
The ice has been relatively stable in its volume for the past 10,000 years. The amount of snowfall over the ice has equally been lost through melt-off and glaciers. However, since the mid-90s, results have shown that the ice is awakening again. The profile and the mass balance of the ice has started to change. The melting of the ice has increased as temperatures have increased over Greenland and the melting season has become longer. The enormous ice currents lead the ice towards the sea through glaciers and fjords, discharging gigantic icebergs into the surrounding ocean at a pace so fast that the process has been given the name ice dynamics. What do the scientists believe to be the reason for these drastic changes? Danish researcher Dorte Dahl Jensen has been working with the understanding of the physics and reasons for the ice dynamics for more than 25 years.
Ice is a material that deforms. It mainly deforms plastically, so if you apply a pressure to the ice, it deforms according to the pressure fields that's put on the ice. So if we look at the Greenland ice sheet, we have a big volume of ice covering the ice sheet. And it's actually the weight of the ice itself that causes a gravity field that presses the ice together, and by that matter the ice flows from the central part out towards the margin of the ice sheet.
This continuous pressure causes the ice to sink further down, forming gigantic ice currents that lead the old ice to the edge of the bedrock. From here it forces its way into the ocean. Contrary to what many may believe, ice is not a static phenomenon. When it moves, it behaves like a liquid, but a very heavy liquid, which means it can move fast. In scientific terms, we're talking about the plastic nature of ice. An elephant foot glacier in northeast Greenland illustrates the phenomenon of ice dynamics. At this location, the ice flows from a high mountain range down on a flat plateau. Snow and ice that have been accumulated in the mountains become sufficiently thick, and this pressures the ice to flow down through valleys and spread out in the lower flat terrain.
The velocity of the fast-flowing ice streams has been monitored during the last 30-40 years, and we have observed for the Jakobshavn ice stream that it's been moving 7 kilometers per year. That's an amazing velocity of an ice stream, but in just few seasons after 2002, it accelerated up to 15 kilometers per year, and that has totally caught us by surprise that an ice stream could change its velocity so fast.
At the edge of the inland ice, the big ice currents are visible. The massive pressure from the ice behind forms these flows, and when the amount of snow is equal to the amount of ice and meltwater leaving the bedrock, the ice is in mass balance. Measurements have shown that while the center of the ice is growing, the mass of the ice along the coast is rapidly decreasing.